Welcome everybody to another Cybr live training session. If you're a repeat guest, welcome back. If you've never attended a Cybr live training session before, welcome. We're glad to have you, especially because I think today is going to be a really important conversation. If you're either already using the cloud, but you're not using some form of infrastructure as code tool, or if you have interests in learning more about cloud, and regardless of whether it's cloud security or just cloud operations in general, but for both of those topics, understanding and being able to use IAC, in my opinion, is super, super important, and probably one of the biggest skills you could learn this year, and or something that you could deploy this year and have a pretty massive impact on your cloud operation. So I hopefully I'm not overselling it here, but it's something that I really, really believe could make a significant impact on your cloud operation. So on that note, Chris, I appreciate you joining us today. Chris and I have known each other for a number of years now. I think we met back in, what was
since
it?
Since the before times.
Yeah, was it 2018 or maybe
it was right when you were right at the end of Linux Academy.
Was it I think it was before that though. I think it was like 2018. It was definitely before 2019. So I want to say either 2017 or 2018, something like that. But yeah, it was great to meet you at reInvent, and you were one of our learners at the time, and so we got to shake hands, do a photo op, and spend some time at reInvent. So yeah, that was a really fun day. I'm glad we were able to meet. And since then, we've stayed in touch. And now I'll let you do your introduction here in a second. But just to preamble that, you're now with HashiCorp, who is maintaining and developed Terraform. So you kind of know what you're talking about. You're also an AWS hero, which is a very high accolade in my book. So I'm propping up Chris here, but he knows his stuff. He's been in the industry for quite a while. So I'm excited to strap in and learn from him. And then also, right before I hand over the reins to the introductions, I wanted to let you know that if you've never attended before, we have a Q&A section. So if you click on the browser tab, you should see some sort of question mark on the Zoho software. You can click on that tab and you can ask us questions. And I'll primarily be here to field those questions today. And so as they come in, I can either wait till Chris has a second to breathe and then pop that question, or we can hold them to the very end and ask the questions at the end. But as you get a question, go ahead and ask it, submit it through the software. That way I get to see it, I get to triage, and we'll go from there. On that note, anything else to add before we get started, Chris?
No, I super love the organic type Q&A, so I will definitely take lots of time to breathe and pause and everything like that so that people can ask questions as we go. I like it to be a bi-directional communication, not just me like clicking a timer and going, okay, now I talk, and then okay, now we have Q&A. Let's just have fun with this.
That sounds good to me. Let's get started.
Cool. All right, folks. Well,
I was gonna say, I think you have screen share, right? Just making
sure.
I do.
Okay, perfect. I do. I have screen share and I have the power. Unless you want it back.
Nope, go for it.
Okay. So in today's session, we are going to talk about introductions. We're going to talk about Terraform and getting started with Terraform on AWS, what Terraform is, why we want to use infrastructure as code. And after we've gotten through the whys, the wherefores, the what's in the hows, we are then going to do some demo, get started with Terraform on AWS. I've got a little GitHub repo that I will share after this as well so that people can jump into it and get started immediately. So about us, let's talk about us for a minute, Christophe and Chris. So my name is Chris Williams. I am the Developer Relations Manager at HashiCorp for North America. With that role, it's actually a really, really fun role. I get to go out into the community, talk about technology, talk about my favorite things, talk about exactly what we're going to be talking about today. I came on there and they said, hey, you want to go out and do things and talk about HashiCorp and Terraform and Vault and all that stuff? And I was like, you mean the thing I do at night for free? And they're like, yes, do that for us. And I was like, oh, sold. So here I am. I am also, as Christophe mentioned, an AWS hero. That means that I enjoy AWS services and products, and I leverage them, and I write and blog about them on my podcast, which is called vBrownBag. It's a show that's been around for about 15 years now. We started off talking about VMware, and as every new technology has come about, we have talked about that, helping people learn and educate. It's a community-driven effort, and so me and my friends do that every Wednesday night. Yeah. So and I'm also an enterprise architect. And what that means is that I've been around the block with Fortune 100 companies literally for almost 15 years now. My previous company, WWT, used to drop me in and do projects as a pro services enterprise architect with all of the Fortune 100s, fixing really horrible, huge, hairy problems in a project-driven method. So yeah, that's me. Christophe, back to you.
Well done on your introduction, Chris. Thank you very much. If you could give me the first bullet point, please, I would appreciate it. Actually, go ahead and put all of them on there. That way it just makes it easier.
There we go.
There's 1, 2, 3, 4. There we go. So like I said earlier, if some of you are coming back from prior Cybr Life training episodes, you've heard my introduction many times before, so I'll keep it short so it doesn't get too boring. But hi, I'm Christophe. I'm the founder and trainer at Cybr, CYBR, where we do AWS security training, and we do it hands-on and practical. So you're not just learning concepts, but you can actually take what we're learning and apply it in production environments. That's really important to me. I think that makes a really big difference when we're talking about training. I have 8+ years of AWS experience, and I come from a background primarily in web development. And so the two kind of married together, where I was learning how to do web development. I was deploying on really crapping hosting providers that I won't name. I think some of them are still around today. And it never worked, or it was super slow. There was issues, it would crash. And so I'm like, okay, I need to figure out how to take my code and actually make it run reliably and make sure that it's always available. How do I do that? And then that led me to learn about the AWS cloud, and then the rest is history after that. So I've loved cloud development and then cloud security for many, many years now. It's just something I truly love doing, and kind of like what you touched on, Chris, something I did on nights and weekends anyway, so might as well get paid to do it professionally as well. Now, I also live in Colorado, in Denver, Colorado area. So if you're ever around, let's go hike. If it's the right season, let's go skiing. Maybe not right now, but later on in the season. Let me know if you're in the area. I'd love to meet up and grab a drink or grab some food and go hiking. But that's it.
Awesome. So we are going to get right into it. What is Terraform? So because of the poll, everybody said that 80% are unfamiliar with it. We're going to go a little bit slow, and as questions pop up, please feel free to drop them into the Q&A. So Terraform is infrastructure as code. It's an automation tool for building, changing, and managing IT environments. Now, what does that mean? When you go into your AWS account and you're in the console and you're clicking around and you're doing all of the things, I'm actually going to just click over to my VPC console here. You go into your EC2 instances or your code build environment and you click on infrastructure and it comes up. And that's great when you're learning AWS, but it is not effective, efficient, or consistent when you are trying to make the same environment perfect over and over and over again, or if you're trying to version control on your environments. So what it does is it allows you to, why isn't that forwarding? There we go. It allows users to define infrastructure as code and deploy it across a variety of infrastructure providers. And we're going to get into what providers means, but it includes public cloud, on-premise environments, containers. We have Terraform interfaces with a bunch of different providers. So for this one example, we are going to be using AWS, but Terraform is leveraged in, as of yesterday's count, 4,275 different providers, which includes AWS, GCP, Kubernetes, Docker, on-prem environments, VMware. That it is leveraged ubiquitously, almost ubiquitously across a bunch of different environments. And it is written using the HashiCorp configuration language. That is, the acronym is HCL. You'll hear them both used interchangeably. So we write code in HCL. And it's very readable. As we get into the demo mode of this, you're going to see like, oh yeah, I know, I totally get what this means. As you scroll down through the HCL, you'll be like, oh, I see exactly how this works. But speaking to the programmer side of it, you can also call variables, you can call functions, you can do looping. It is a declarative language that allows you to declare what you want your state to be. And then Terraform goes out, looks at your environment, matches up, and we're going to go into all the different things about init and apply and all that stuff as well, matches what your current environment looks like versus what your declared state is in your TF file, and then makes it so, makes the changes to make it declare the state of it. So what the normal evolution, the normal use case for it is, you start off with a small environment, you deploy a couple of little things, and then you start iterating. By using a version control software such as GitHub or GitLab, you can then start iterating on different versions. You can tag like a smaller environment, and then it can grow up and start turning into a bigger environment. And the best thing about version control, of course, is that you can then roll back. Oops, I made a mistake. We have to quickly roll back. Let's undo this thing. You don't have to quickly click on the EC2 instance and right click, shut down, terminate. Oh crap, I did the wrong server. I meant to do the other server. And then it's so by leveraging infrastructure as code, you're creating a couple of safeguards. You're also creating a couple of ways to, also shoot yourself in the foot really, really quickly. But if you're careful and you use version control, and you make sure that your state file, and we're going to get into all of this, are in a safe place, it is a extraordinarily powerful tool that is being leveraged by the largest organizations in the largest environments. And skilling up on infrastructure as code is, as Christophe said, extraordinarily important when you're learning how to get into the DevOps space, and the security space as well, because by being able to read it, you can then figure out what's happening as the infrastructure is being deployed. Okay, so there's 4 main components, and they're all interrelated. They're all equally important. And as we go through the rest of the presentation, we're going to be talking more about each one of them. Terraform Core is the statically compiled binary that you download and install onto your system. It is written in Go, and it is from that command line interface that you then do your Terraform init, your apply, your destroy, your plan, and your validate, as well as all of the local commands that you do. It is connected via the rest of the world via Terraform provider plugins. Provider plugins are responsible for managing the life cycle of specific resources from a particular provider. So when I said the 4,275 providers, like one of the providers is AWS, another one of the providers is Azure, another one of the providers is Docker. You add providers to your script, and then you can then go forth and manipulate that particular type of resource. So the core works without either one of those, you don't have anything. You have to have both the core and the provider to go do the things. And when I say the things, I mean the actual code itself. So the HCL that I was speaking about before. So you take your HCL code, you run it through the core figures out which providers it needs to deploy your resources. And then once all of that happens, after the resources are provided, your state file is updated. And the state file is responsible for tracking the state of your infrastructure as the stuff that's managed by Terraform specifically, and that's a very important distinction. The state file holds the current state of all the managed resources, and it captures details about the resources, including resources, attributes, dependencies, and in some cases, it actually has like secret information. So like if you're deploying a database, then it'll also have the username and password for getting into that database. So the state file, and I put a little lock on the front of the state file, is very important to have in a safe place and in a backed up place as well. So when you're first learning how to do Terraform, you're usually your backend, where the state file goes, is we call it the backend. The backend is usually a local file, and when we deploy stuff in our demo, it's going to be on a local file. When you graduate and you start working for a company, that state file must never be on a local system. It has to be in a version controlled, protected environment, because it is literally your state. It's what everything looks like. It's what Terraform Core references to make sure that when it's making a plan, when it's trying to create a plan to make a change, it references state. When you're refreshing the environment and you want to do a validation, it looks at state. It is Very, very important. And not only do you always want to make sure that it's in a safe place, you never want to edit it manually. Editing your state file manually is a very advanced process. And you definitely want to have somebody that has been in Terraform for years and years and years, doing it before anybody else even thinks about doing it. Okay, sorry. As you can tell, I've been burnt a lot. So these are the scars coming out right now.
It's the enterprise architect coming out.
Yeah. Save your state file in a locked place that nobody has access to, because you don't want your secrets to get out, and don't edit it manually yourself. There's tools for importing resources and doing things that are much easier and safer. Okay, so I said all that to say this. Now we're going to get into providers and resources. The providers, so that was the second thing, the little plug. The providers allow Terraform to interact with APIs and services. I'm just gonna build this out. It is responsible for managing your lifecycle. It is the interaction for the APIs of the service. So all of the cloud platforms interact via APIs. When you're clicking around on the console, you're actually making an API call to a backend in the service. This is basically shortcutting that and going straight to the API. Each provider defines the types of resources and data sources that Terraform can manage for a specific service. So VPC is a service, EC2 is a service, load balancers is a service, security gateways are a service. All of them have resource blocks and calls and attributes within Terraform that you manipulate to link them all together and work together. Configurations can be done directly in the Terraform config file, but certain things, specifically access keys, must never be put inside of the provider block. So when I say the provider block, each one of these providers gets a provider block in the Terraform config file, and then you then specify the information that you want in the provider block. And we're going to get into provider block. So I'm sorry, I'm kind of bouncing. There's a lot to cover, and so I'm getting a little bit ahead of myself, but hopefully this all comes around full circle at the end. In your provider block that you create inside of your config file, you have the information that you want to then leverage for that resource. So for the AWS provider, you specify what region you're going to be working out of. You specify how you're going to be accessing it. If you're using multiple regions, then you have to have aliases inside of your provider. There's a lot that goes into the provider. But when you run Terraform init, which is the first command that you do inside of any new environment, Terraform goes and downloads the required provider plugins for said resource. So if you've got a Terraform config with AWS resources in it, the core goes out and pulls the provider binaries into the working directory that we're in. And you're going to see this in the demo as well. And Terraform also supports custom providers, which allows our customers and companies to create like internal providers for API calls that they don't want to be seen as publicly facing interfaces. One very enterprising young person created a Domino's provider so that they could order pizza using Terraform. They created data resources and data points, and now they can order Domino's pizza because Domino's has an open API that you can access and interface with. Anything that has an API, you can use Terraform to do things with it, as long as it's written properly. It's really, really cool. Okay, so I told you all of that so I could say this. The biggest benefit, the biggest bang from Terraform is that you can replicate consistently across environments. So you're building out this development environment for the company that you're working for. You've created your EC2 instances, you've got your load balancers, you've got your backend S3 bucket, you've got RDS on the backend, and your developers are happy with your development environment. So now that you've got this stood up, you can tag this, you can version it, and you can say, okay, this is great. This is now our production environment. All you have to do is change a couple of variables, and now it is writing to a different environment on a different region with bigger EC2 instance types or different parameters and controls. Maybe your autoscale group has 10 boxes instead of 2 boxes, and you can control all of that via Terraform and tagging so that you can just have that. And then, of course, somebody else is going to say, okay, well, that's great, but now I want UAT performance and staging. Well, guess what? You can do the exact same environment consistently, repeatably, and manage all of that just from one script with a couple of version controlled variables, so that when you make a change in development, say the developers now want to add a new additional service, they want to have containers and ECS services in there, you add it into development, they like it there, and then you can push to the different environments. So you push those changes to prod, UAT, staging, and perf, just like you would in a regular development lifecycle. In fact, we actually call this the infrastructure lifecycle management. It's, ILM, much like a software lifecycle management, we now have infrastructure lifecycle management. This is how your infrastructure is spun up and then ultimately destroyed. Any questions as we're going through? I know I'm going really fast. I apologize.
There is a question. I think you partially answered it already, and I'll throw in my hat as well. But it's let me go ahead and project it so we can answer. So the question was, what is the difference between Terraform and AWS CloudFormation? I'll get started if you want me, Chris, and then you can.
Yeah, it's a great question. Go ahead.
It's a really good question. You already partially answered it, in my opinion, because you mentioned how Terraform has all these different providers. AWS CloudFormation doesn't have that, right? AWS CloudFormation is built for AWS, and so it's not going to be able to deploy resources into Azure, into Google Cloud, Docker. It's not going to be able to order Domino's Pizza, probably. I mean, you could actually build AWS infrastructure that would do that, but it'd be a lot more work, and it would not be fun. Whereas Terraform, you can use it across those different platforms. So if you're multi-cloud, if you run in Azure, if you run in AWS, something like Terraform takes that step back and says, I can do that. I don't care if you're on AWS or Azure, I can do both of those for you. So that's one example. The other example, and this is just the other benefit to me, at least, is because I use both currently in production, is CloudFormation is frankly such a pain to work with. It is not enjoyable. It's so frustrating. It just doesn't work the way that you want it to work. And when it doesn't work, you waste so much time trying to troubleshoot. Like, no offense to the CloudFormation team, you guys have built a wonderful tool, but at the same time, it's such a frustrating tool. When I work with Terraform, for the most part, it does what I want it to do. It does what I expect it to. You do have to learn HCL. It's really easy to learn. And once you learn it, you're like, you know what? This is easier to read. This is better. This is more enjoyable. So from personal experience, I have to use both for various reasons. But if I had to choose one, easily would choose Terraform over CloudFormation. Chris.
Yeah, and I mean that is a fantastic answer, and you said some things that I'm not allowed to say. Well, no, it's not. Am I not allowed to say? I don't know. So I don't like to. I mean, every tool has a purpose, and because I came from enterprise architecture, I try not. I just the tool. I'm trying to be tool agnostic until I talk to the customer and figure out what their use cases and needs are. One of the reasons why I like Terraform as much as I do is that not only if you're say you're just in AWS and you're only using your environments are built on AWS, even with that, chances are you're going to have things and systems inside of your environment that are not AWS. Like if you go to the AWS marketplace and leverage tools and appliances that are written by third parties, those third-party tools and appliances also have Terraform providers. So it's a one-stop shop. Your HCL config can be a one-stop shop, not only for managing your just AWS services, but those third-party providers on top of your AWS environment. So for the folks that say, well, I only use AWS, and so I'm going to stick with CloudFormation, I'm like, okay, great. Well, as long as you don't have any other third-party services in there, you're good to go. They're like, whoa, wait a minute. We've got Palo Alto, we've got Datadog, we've got this, we've got that. I was like, oh, well, in that case, then you might want to think about, using Terraform to, just do everything. But again, that's use case specific, customer specific. But I work for HashiCorp, so obviously I'm pro Terraform. Cool. Yeah, that was a fantastic answer, Christophe.
I appreciate it. Thank you. A couple more questions before we move on, and it'll give you a little bit more of a break as well. And I think they're very relevant here. The first one is more of a statement than a question. I like it. If you have anything to add, go for it. But it says CDK-TF to the rescue then. Can you elaborate a little bit more about using something like CDK versus HCL, what that even means, and things like that?
So CDKTF, I'm actually a big fan of. It is the CDK. It's the HashiCorp CDK written. So if you know Python, then the CDK might be a better entry point for you. Like if you know Python and you're vehemently against learning HCL. I don't know why you would be, because they're very similar, but you want to use the CDK, then you can leverage that as well. It is a happy medium for the hardcore programmer that doesn't want to. I mean, I don't want to get too much into the CDK, because this is a Terraform talk, but it's definitely an option for those that are interested in that. If you have gone down the Terraform path and you love it, but you're like, oh, if only I could do this in Terraform in Python, then that is potentially an option for you.
Or if you love TypeScript, you could also do it in TypeScript as well. There's more than just Python and TypeScript. I can't remember what the other options are, but
I give it short shrift. I'm a Python guy, so I just say that. But you're absolutely right. It's available in multiple languages.
Fair enough. The next one, and then we'll move on, is asking, what is the best tool to use IAC? For example, I use VS Code. Can I use VS Code for Terraform? The answer is absolutely yes. And I just searched for the extension that I'll send you here. So if anybody's interested, I think you'll be able to see the link I just pasted. That takes you to the Visual Studio HashiCorp Terraform extension that you can enable, install on your device, and then you can use that natively in VS Code. It's beautiful.
Yeah, I also use VS Code for most things. Excuse me. I also have PyCharm installed and a couple of other things installed, but my primary go-to is VS Code with the Terraform extension.
All right, we've got more questions coming in, but let's keep moving forward, and then we'll circle back to those questions.
Okay, yeah, and we might be answering those questions as we go. So now we're going to get into the Terraform basics. These are the big commands that you are going to, as a beginner, as you get started, these are the commands that you need to know. And these are what you type into the core. This is what you type into the executable after you've installed it. And I'm going to put up a link on how to get the install done and everything too. So the first thing that you do as a happy little mohawked, I don't have a mohawk anymore, but I used to back in the day. As a happy developer, you create your Terraform config file. This can be very short, as you're going to see, or it can be, a huge modularized multi-folder environment. Each module in Terraform is a folder structure. So if you've got multiple folders, if you're looking at some Terraform code and you've got subfolders in there, consider each one of those a module, and then the base folder is your root module, and then you've got children modules. It is the local. This is where you run Terraform init. And Terraform init is the initialization of your working directory. What Terraform init does is it reads through your Terraform config file, locates what providers are necessary to run your environment, and it installs those provider plugins based upon the specs specified and typed out by you. If a backend has been specified in your config file, it will then set up your backend. Common backends include local files for beginners, HCP Terraform, formerly known as Terraform Cloud, AWS S3 buckets. As long as it's protected, encrypted, and not on your local system, that's what you want to go for. It also retrieves any module specified in the configuration. So providers and modules are two different things. And it ensures that your environment is properly configured so that subsequent plan applies can run smoothly. So that's the very first thing that you're going to do inside of a folder. Like as you're doing something, the very first thing that you're going to do is grab your providers by running Terraform init. The next thing that you're going to do is you're going to run Terraform plan. And these are the actual commands. So you're going to type out Terraform space plan. And what Terraform plan does is it compares the current state of your environment in your target to what's written in your configuration file. If you have nothing in your target environment, then it's going to tell you, okay, these are all the things that I'm going to build. If you've already got something and you're making small changes, it will then say, okay, these are the things that I'm going to modify, change, delete, add. Basically what it does is it looks at your desired state, looks at your current state, and then the plan tells you a summary of the changes that will be made without actually applying those changes. So planning is just planning. You can plan and then not save to an out file, or you can do a dash out and save it for your plan for a future apply that you want to configure. Validate is also one of my favorite Terraform commands. What validate does is ensures that your files are syntactically correct. Planning sets up your environment and makes sure and basically defines what's going to be changed. Validate goes into and checks for logical errors. It checks for referenced resources and data sources, makes sure that they're valid and correctly defined according to the provider specs. And it also ensures that the provider configs are correct and that all of the required arguments are logically stepped out and syntactically correct. All right. The next thing that you're going to do is the magic sauce. This is Terraform apply. This is where Terraform actually connects with the provider connects with the, I forgot to mention this before, the Terraform core communicates with the provider via RPC, for any developers out there, in case you care. Sorry about that, where was I? So the Terraform core, you type in Terraform apply, it connects to the provider connects via API to the target environment and deploys all of your resources. It sets everything up based upon your specs. And once that is finished, it then updates your state file. So the state, once the apply has been successfully completed, your state file is updated with all of the changes. And then that is the entire lifecycle. Now you have a running environment in whichever cloud provider or local provider you're leveraging and influencing. And then you go back and you edit it. If you need to make any changes, you go through this entire process before, with the exception of Terraform init. So you make a change, you can then do a plan, see what changes are going to be made, run a validate. And you actually don't have to do the plan or the validate. You can just skip to Terraform apply. Don't. Make sure that you just know what you're getting into with a plan and a validate before just hitting apply. I've seen a lot of bad things happen for people that try to skip steps. I'm not going to say it's best practice to go through all of them because then I'll be pilloried, but it's, just, tread with caution. And of course, the final ultimate command is Terraform destroy. And what that does is exactly what it says. It creates a destruction plan. It tells you, are you sure you want to do this? And then you say yes, and then it deletes all of the resources under management by Terraform. Again, I say that because that's super important, because if you have created an environment and then somebody else went into the console and started doing a bunch of stuff and changing things and moving stuff around and making new resources, your Terraform destroy will only destroy the things that it knows from in the state file. And then once that's finished, it then updates the state file. So when you start deploying stuff using infrastructure as code, it is very important to maintain not security, not rigor, discipline. It's important to maintain non-console use discipline on your team. That's also something that will come back to bite you in the butt. Okay. We're going to get into HCL, the syntax of the actual resources themselves now. Christophe, anything pop up from the questions that we need to address first?
Yeah, let's address this one real quick here, which is asking, is Terraform only used to create resources and destroy? If yes, are there any other use cases of Terraform?
Create and destroy resources. I mean, you can modify and change resources. If you're in a brownfield environment, you can import existing resources. So the big use case for Terraform is a company starts using the cloud. They get their feet wet with it. They really love it. They've deployed a bunch of infrastructure, and then they're like, oh no, we should be using infrastructure as code. And that is a far more common scenario than running things greenfield. And when I say greenfield, I mean you start off using Terraform and then you have like a pristine environment. A brownfield environment means that stuff has been spun up in the console, and you then subsequently need to import your resources into Terraform without breaking things, without ruining your existing environment, and making sure that everything is still up and running, but now under management via Terraform. So that is another primary use case for it. Yeah. Okay, so the HCL syntax. Most of your HCL syntax is going to show up in this format. You've got your block name, you've got your parameters, and then encapsulated in brackets, you're going to have your key value pairs. And your key value pairs can be nested. You can also have subsequent additional key value pair nests. I call them dictionaries because I came from Python, so I'm just going to say dictionaries, but know that, you know, whatever language you use, just say curly brackets. So you've got your block, your parameters, and then your attributes. A real life example of this is this resource. And okay, actually, let me step back. Your blocks can be resources, they can be variables. There's a number of block types that you're going to leverage inside of Terraform. Resources are the most important one. That's your actual resources, the things that you're going to be deploying. But you've also got variables, you've also got outputs so that you can feed your information into other modules, your provider, so that you can actually tell Terraform which provider you're going to be using and at which version, modules, so that you can call additional resources from different places, data, locals, and Terraform. There's a bunch of different block types. That's what I want you to know. So in this example, we've got a resource. And if you took this block of code and put it into a Terraform config file and hit Terraform init, Terraform plan, Terraform validate, Terraform apply, this would spin up an EC2 instance in your AWS environment if you still have your default VPC running. If you've deleted your default VPC, then this won't actually work. But for this purpose, we have the block name. And again, the block name can be resource, variable, output, provider. There's a bunch of different ones. The AWS instance name is the resource type. And the resource type name is the functional name provided by the AWS provider. So if you go into, okay, so here we go. So these are all of the different providers that have a provider written for Terraform. If you go into AWS and then you click on documentation, and then I'm just going to pull up AWS _ instance. This is the example usage patterns of standing up a resource type. And this resource type is how AWS knows that you're standing up an EC2 instance. So this instance name is, you have to use this name. The second name on here is the resource name, which is your local, I don't want to say variable name because variable is actually, this is your local name. This name can be anything that you want it to be. This could be Chris's Happy 101 server or Christophe's, cybersecurity server. As long as you're consistent with, and this name is how you leverage and reference this particular resource in the rest of your Terraform code. So as long as you remember this, then you can use, it can be whatever you want it to be. And then you have all of the arguments that the provider needs to actually stand up this instance. So because this AMI is in US East 1, you have to have this information in there and you have to have the instance type. And these are the only two arguments that you need to stand up an EC2 instance. There's a bunch of other instance arguments. Oops. There's a bunch of other arguments that you can provide that are not required. They're optional. And you can go into the argument references and figure out which ones are optional, which ones are required. The documentation is very, very granular and it's excellent. And basically anything that you want to do with an EC2 instance, you can do it through Terraform and through these arguments. And so that is how a provider block works. Excuse me, this is how a resource block works. Okay, so in order to get going with a demo, everybody in the audience who's watching this in the future, if you haven't already installed or set up Terraform, you go to developer.hashicorp.com/terraform/install. If you are running on, you can install it on Windows, Mac, or Linux. If you're using Brew, then it's brew space tap space HashiCorp/tap, and then brew install HashiCorp/tap/Terraform, or hit the QR code and you'll get Terraform installed. Is there anything else that I want to qualify for that? Once you've installed it, verify the installation by typing Terraform space -version. And the other piece of the other binary that you'll need to run this is your AWS CLI. So you have to have the AWS CLI installed locally so that Terraform can communicate with the AWS provider using the configuration. You know what? Yeah, never mind. Sorry, I was getting ahead of myself in my own brain, and I fudged it. Okay, so you need Terraform. You need to install Terraform locally. You need to install the AWS CLI locally, and then you need to run through basically you need to create secret access keys and regular access keys. There is a plethora of information on the internet. I'm not going to get into it, and I've already set up my TF-vars file, my environment variables locally, because I don't want to put my access keys and secret access keys on the internet for people to watch and create a Bitcoin farming environment in my system. So I've already
that. That's unfortunate, man.
Yeah.
I had my CLI ready to go. Type in your credentials.
So nobody's going to see my secret access keys or anything like that. In order to do this demo, you have to have Terraform binaries installed, AWS CLI binaries installed, and your Terraform local environment variable set up. And all of that is very easily Googleable. I didn't want to get into that during this because we've got a short period of time. So I wanted to get into the demo quickly. So let's do exactly that. All right, we have, oh, why isn't this over there? Oh, I gotta go. Oh. Okay, there we go. All right. Did I share the screen? Can you see that command line interface?
Yes.
Okay, cool. All right. So now we are going to get into it. Where did I put? There it is.
And just as an FYI, there's maybe a 1 second delay, 1 to 2 seconds delay as you type for us to be able to see it. So just keep that in mind as you're talking about it.
Oh, okay. So I am going to make a Cybr folder. I'm going to CD into the Cybr folder, and I'm going to bring up VS Code. So inside of VS Code, I'm going to create a new file, and the convention is main.tf, but any file that is in this folder that has the .tf extension will be read by Terraform. So you can name the folder, you can name the file anything that you want it to be. In fact, we're going to create another file. And most modules, if you look at them, there's going to be variables, outputs, inputs, resources, Terraform file types in there. Terraform reads all of them as long as they have .tf or .tf-vars. There's a couple of other things, but we're not going to get into that for a beginner class. So the first thing that I'm going to do is I'm not going to type all of this out. I'm just going to paste it in here, and then I'm going to walk us through it. So this is the first resource block. The resource type is AWS VPC, and the name that I've given it is app. Again, this name can be anything. And the arguments that I'm passing into it is the CIDR block for the VPC and another required information enabled DNS host names equals true. So your primitive types are strings, booleans, integers, the regular stuff that you would normally have. Another resource is your internet gateway, and this is referencing via this name the VPC ID. So this resource, AWS Internet Gateway, requires the information of the VPC ID, and we are pulling that information from AWS VPC app, and then the name of, and then the information which is ID. And that information you get from the documentation for the AWS provider on the HashiCorp website. Again, another resource that we're going to spin up is a subnet within the VPC. So it references the VPC. We're using a string for a CIDR block, and we're giving it another bit of information to map the public IP on launch. A bit of routing information, referencing the VPC ID again, and then here's a sub block for the route itself, passing in the gateway ID information, another resource, yada, yada, yada. And then here's a security group. And these are security people, so I'm assuming that they have a passing familiarity with networking and security groups. do we need to, we don't need to turn this into a networking or a security class.
Yeah, let's go ahead and skip that because that could be another whole conversation.
Okay, all right, cool. Okay, so we're going to bring up the console, and the very first thing that we're going to do is we're going to type Terraform init. Now what Terraform is doing is, now you'll notice that I did not put in a provider block into this script. Terraform is smart enough to know, oh, you're calling AWS VPC, you're calling AWS Internet Gateway, you need the AWS provider. So I didn't put in the provider block. And to be clear, you should put in the provider block, but I was just using this as an example of Terraform can figure stuff out. It can't figure everything out, so you should be explicit with it. But if you just put in like an EC2 instance, it'll say, okay, I'm gonna go grab the AWS provider and go stand this thing up. There's a lot of places where that doesn't work, so don't do this at home. But we now have successfully stood up the Terraform init environment. And what that did is it created this new folder. You'll see this dot file here, and it pulled down all of the information for the AWS provider, including the version that I pulled down. So version 5.55.0. It also created a Terraform lock file that holds the information and the hash for that provider, so that in the future, as I'm reusing this, I can pin it to this provider version for future builds if I want to leverage a feature or an attribute that is specific to this particular provider. So now that I've done that, I am going to type, oh, you know what? I actually have an alias in here. So I always type TF, but I'm going to type Terraform because I don't want to confuse anybody. So the next phase is Terraform plan. Terraform is now looking at the local state file, figuring out what needs to be changed. And because there was no state file, it says, okay, I'm going to be building this from scratch. This is a greenfield deployment. I now know that these are the resources that are going to be created if I decide to do a Terraform apply. So all of the green pluses are creations. If we were modifying something, it would be a squiggly yellow for a change, or a tilde red for a delete. And you're going to see both of those in a second. So we've got that. We didn't, and as you can see here, you didn't use the out option to save this plan. So Terraform can't guarantee to take exactly these actions if you run a Terraform apply now. Well, we're still not going to do that. What we're going to do is we're going to do a Terraform validate. And if we had something like, say, this app ID was not referenced, say this was app1, oops, instead of calling it properly, we called app1 instead of app, and we ran Terraform validate. Terraform would choke on that and say, oh, there's an undeclared resource. You've got app1 on line 13. And sometimes it's smart enough to go, did you mean app instead of app1? But I don't know if it's going to do that for, anyway. So let's change this back. Run validate again, make sure everything is clean. And now we're going to type Terraform apply. Oh, if I could type Terraform. And what am I? See, this is what happens when I type TF too many times. I've forgotten how to type Terraform.
This is why you have an alias.
Terraform apply. There we go. Okay, it is now basically giving me the exact same plan once again, and it's asking me, do I want to deploy this? And the only valid answer that you can type in here is yes. If you type in anything else, even just the letter Y, it'll not accept it and it'll crap out. Okay, so it is now building my environment. And if you look in the VPC console and hit refresh, you will see that that went from a 1 to a 2. So I now have 2 environments, and this is the one that we just stood up. I didn't put anything in there because EC2 instances take a couple of minutes to spool up, and I didn't want to go through that. So that is how you do that. Okay. So now that we've made an environment, let's say that we didn't want to use these security gateways. So we want to change this from port 80 to port 88. because port 80 is massively overused. So what we're going to do is we are now going to, I'm going to type TF just so I don't screw it up again. We are now going to do a TF plan again. Terraform is looking at the environment, looking at the old state file versus what we want to change it to, and is now saying, oh, I see that you want to make a modification. So it's going to do an in-place update. It's going to delete this ingress rule, and it's going to create this ingress rule and make this modification. So if I want to change that, then I type in TF apply. And now, and boom, it's done. So now that we've done that, what we're going to do is we're actually going to create, how are we doing on time, Christophe? I don't want to overblow it.
We're approaching the end of our scheduled time. If you have a little bit of extra time, we can go over. I don't have anything after this, so it's solely up to you at this point.
Okay, you know what? I'm just going to put in a variables file just to show the some of TF. Okay, so now that we've got a variables file, this is the power of Terraform. I've got a bunch of variables, and what I want to do is I want to inject these variables into, you never want to statically code information. So having a static CIDR block means that you can't reuse this file. If we create a variables file and then leverage that information, so enable DNS host names, if I then use the var keyword and push this in here, it will now reference the variable. And now you can have multiple different variable options to choose from for this information. So I'm going to change my CIDR block to, what did I use? VPC CIDR block. And my public subnet to var.vpc subnet 1 CIDR block. And my map to var.map public IP on launch. And that's good enough. So what I've done is I've mapped them to variables, but I haven't changed any information. So now if I run a TF plan, even though I've moved the variables in there and referenced a different file, there's no changes to the environment. So we've made this file much more flexible and much more modularly usable for the future without actually changing the environment itself, which is going to make your production people breathe a sigh of relief. So the final thing, when you're done with everything, when you're done playing with everything, you don't do this in production, is you type Terraform destroy, and it asks you, are you sure you want to do that? Why is it? Okay, there we go. It says, are you sure you want to do that? And you say yes. And now all of that information that we spun up is gone. All of those resources are deleted, and and hold on. Let me get back to the state file.
You're doing that. I will add that one of the differences between CloudFormation and Terraform, again, to answer that question, is when you try to destroy in CloudFormation, a lot of times some of those resources just simply won't destroy. And then there's dependencies, there's issues like that where you have to either manually go in and delete those or write a script or something like that. In my experience, Terraform just does a better job of destroying things, and that's very much appreciated. It saves a ton of time.
So Terraform is really good at creating a dependency graph of what things need to be destroyed before and after other things. And there's some tree commands, and I'm going to put up a link to an article that I wrote that walks you through how to create a graph tree of the resources and why Terraform will build things before other things. And there's actually keywords that you can use called a word called depends on, so that you can manually pin a resource to not be created before another resource is done. But 9 times out of 10, you're not going to use that for regular stuff because Terraform is already really, really good at understanding that dependency graph of the services. So the Terraform state file, so currently it has nothing in there because I already hit destroy, but previously, and this is the backup file that it keeps of it, this was all of the information that was in the state file before we hit destroy. The current state of the environment is destroyed, so there's no information left in state. And again, this is something that you want to have in your production environment. You want to have this protected, passworded, and unavailable to anybody except for the few that actually are leveraging Terraform. So that is almost the end. If you want to screenshot this, there are tutorials and docs from the HashiCorp website. The tutorials are absolutely excellent. I super encourage you to do them. One of the good getting started ones is a Docker one that you can run locally if you have Docker Desktop installed, or if you're comfortable with Docker. There's a bunch of AWS and Azure and all of the flavors of different clouds. You can run tutorials on all of them as well. The docs link is the link to the providers and the modules and the resources. And I recently wrote a free code camp article on studying for and passing the AWS associate certification. So if you want to take a look at that, that is, if you read that article and do the steps in there, I guarantee you will absolutely pass the AWS associate certification. So yeah, that's it. I'm done.
Good to know on that. Thank you, Chris. I really appreciate it. Just a quick mention of Cybr, and then we'll wrap up and answer a couple of last-minute questions here. But if you're interested in AWS cloud security training and you haven't heard of Cybr before, check us out at cybr.com. We have courses, we have hands-on labs, and we even have ebooks and other live training sessions like this. We cover all kinds of topics related to AWS security. I will say we don't currently have any Terraform training itself, but that's probably coming down at some point, just because, like I mentioned at the beginning, Terraform can have a pretty big impact on your cloud operations, including cloud security. So
you should do Vault training. Vault training is a shoo-in for a security company. Absolutely.
Yeah. Vault helps you manage your secrets, like if you've got passwords or things like that we mentioned earlier. So that's another one that I can't say much more at the moment, but that will definitely be coming at some point. If you want to flip to the last slide.
Oh, yep.
We'll leave that last slide up as we answer the questions. That way, if people are interested in connecting, you can find our LinkedIn information there. I know Chris is fairly active on LinkedIn. I am as well. So feel free to connect with us if we're not already connected. And we also have some upcoming webinars, or I call them webinars, live training sessions. You can find them at cybr.com/webinars there in the bottom right corner. So check those out and register for any upcoming ones if you're interested. A couple things as we wrap up here, Chris, if you have about 5 more minutes.
Oh, totally.
Perfect. We've got 2 questions related to EC2 instances and Terraform. So let's start with this one. The question goes, why EC2 instance destroyed and created on every Terraform apply command? Is there any way to fix it? So just to provide context to that, sometimes when you type Terraform apply, as we saw with Chris doing it, if you make modifications, if it's a resource, it might get replaced entirely. So that prior resource might get destroyed, and then a new one might get spun up in place. So that's the context behind that.
Yeah, it depends on the type of change that you are making. So if you are making so this isn't a Terraform thing. This is actually an AWS thing. Whatever the change is that's happening, if it's a I'm going to say breaking change because I don't know what the proper term is for it. If it's a change that requires you to destroy, like if you're changing the instance type, then obviously it's going to do that. I don't have a comprehensive list of all of the different types of changes that would require you to kill and recreate the EC2 instance, but I know it's fairly extensive. So it's not a Terraform thing so much as it is just, that's how the service provider manually modifies changes. You might be able to get away with it in the console, but something on the API in the back end doesn't speak to it. You know what? I haven't spent a lot of time on this, so I don't want to give out false information, but that's definitely something that you can dig into as you're making the changes, and it'll specify it in your plan. Is this going to delete and recreate the instance?
And I think this might be wrong. You want to double check this, but I think there's a flag you can set that would prevent the deletion and probably errors out or gives you a warning and says, if you do this, it would destroy it. And then you can always backtrack. But like Chris said, some of that is the restriction of the cloud provider. So there's really not much you can do around it. But the beauty of using something like Terraform is you can get to a point. Sometimes you have to use other tooling. Maybe you want to use something like Ansible as well to manage stuff on the actual instance itself. But you should get to a point where creating and destroying these resources doesn't affect too much. Obviously, in production, it can be a little bit different. If you're relying on just one EC2 instance and that instance goes down and you bring a new one up, there might be a few minutes where things aren't running properly, but you can build around that. You can learn how to build it so that maybe you spin up another instance side by side. You use a load balancer to send the traffic to that other instance. There are ways around this, is what I'm trying to say, that do get a little bit more complicated, but it's definitely a solvable problem.
As Werner Vogel says, everything breaks all the time. Plan for it.
That's a very good thing. And shooing into this next question here, which is, can you run terminal commands on the EC2 instance using Terraform?
Yes, absolutely. That's a little bit more of that gets into some of the advanced stuff that I would have loved to have talked about, but you can run it on an EC2 instance that has Terraform installed. You can use it. So GitHub Actions has runners, and they have to. And so there's a number of ways that you can influence and modify your Terraform config files. Running them locally is the easiest method of learning how to do it and get into it. But if you've got an entire environment spooled up in AWS and you want to use an EC2 instance to do the Terraform manipulation, then I encourage that. However, what I do not encourage is a chicken and egg situation where you have the instance that you're doing Terraform from being managed by Terraform. So if you do that, then you could actually really hose yourself. And I've seen this happen a number of times. The thing that you're pushing from, make sure that is itself not being managed by the script that you're using for the push.
I feel like there's a story behind that. I wish we had more time to explore it, but you can sense the emotions behind that statement. That very wise statement.
Yeah.
If we have any last minute questions, now is the opportunity to do that. But otherwise, we're going to wrap up here. And Chris, thank you so much. As we exit off, I'm going to start another poll that's just simply asking whether you'd be interested in attending more live training sessions on Terraform. So maybe even picking up where we left off here and actually showing more of those tactical commands with EC2 or even containers, things like that, running on the AWS. This was a really great introduction. Thank you so much, Chris. Please give us some feedback on if you want more. And if we get enough answers, actually everybody 100% yes. So that's a good sign. This is looking good, Chris. I think we should schedule a next session that goes into a bit more detail. So
huzzah. I'd be happy to.
Anything else you want to add before we end off here?
No, if anybody wants to reach out to me, Christophe put the LinkedIn link up there. Feel free to reach out to me. And I enjoy doing these. I have a blast.
One more thing actually that just popped up that I think would be beneficial is asking if you can link that blog post that you were referencing from Free Code Camp.
Oh, yeah. It is right here. Actually, if you go to Free Code Camp and type in Terraform, it's this one with my big dumb head on it. It's a lot. I mean, this is not a short article. There's a lot in here, but I go through the different domains. I go through the preparation material, all the free resources, and then I get into the actual domains that you're going to study for, and all of the
That's not an article. That's a full course. That's it is very nice. It's have taken you a while to put together, so thank you for doing that.
Oh, absolutely. It was my pleasure.
All right. Thanks, Chris. And thanks, everybody, for attending. And we will see you next time for another live training session.
Awesome. Bye, team.
Bye.